Hi everyone, from the circuit above, we are asked to determine the Aro total, which is the total resistance of a series circuit. So we will write solution. We know that one of the characteristics or behavior of a series circuit is that current is the same throughout the network, but the value of voltage differs in a series circuit. So with that statement, since the current is the same throughout the network, which is I will be equals to the current that will flow through resistor R1 will be I1 equals to the current that will flow through resistor R2 will be I2, and the current that will flow through resistor R3 will be what? I3. Since the current is the same throughout the network, but for voltage differs, which means the supply voltage, which is V, will be equals to what? The sum of the what? The individual voltage that drop across each of the what? Resistor, which will be V1 plus V2 and plus the voltage that drop across the resistor what? R3, which is V3. This will be equation 2. What is our aim? Our aim is to find the value of voltage or the value of the element that differs in this series network, which is what? Voltage. But we know that from Ohm's law, we know that V is equals to I arrow. So from Ohm's law, which is V equals to I arrow, and from here we are plotting V from this Ohm's law. So we look for these other values of voltage that differs in this network and now substitute it or put it into equation 2. By doing that, we will now know or get the equivalent resistance of a series circuit. So for V1, with respect to Ohm's law, V1 will be equals to what? With respect to this Ohm's circuit, will be I R1. For V2, with respect to Ohm's law, it will be what? I what? 2. And for V3, with respect to Ohm's law, will be I 3. So we can call the whole of this equation 3. Now that we have gotten the value of voltage that differs in the network, we will now substitute equation 3 into equation 2 for us to get our equivalent resistance of a series circuit. So let me bring down the equation 2 down, which is V is equals to V1 plus V2 plus V3. So by putting equation 3 into this equation, we will have that the value of V is I arrow, which is the Ohm's law. So V will be I arrow. The value of V1 is I arrow 1 plus the value of V2 is I arrow 2 plus the value of V3 is I arrow 3. So from this expression, we know that something is common here, which is I. So since I is common, we are going to factorize the value of I that is common from this expression. So we have that I arrow is equals to, by factorizing I, we have that I into bracket arrow 1 plus arrow 2 and plus arrow 3. What are we looking for is arrow, which is the arrow equivalent, which is the arrow total, the total resistance of a what? Series network. So for us to make this stand on its own, we will divide both sides by the coefficients of what? Arrow, which is the equivalent resistance. So by dividing both sides, we will have here that here will be I, we divide here by I. So I will take away I. These idiots will take away these other idiots. We will have that arrow which is the equivalent resistance of a series circuit will be equals to R1 plus R2 plus R3. So this is the equivalent resistance of a series circuit. It's very simple. I would like for you, if you find this video helpful, tap like and comment yes if you find this video helpful, or if you want me to make more videos like this. Bye.